Hello, and welcome to our mini project. Today, we're going to be discussing the impact of the topological sort algorithm and how its usage in electronic spreadsheets has impacted business, particularly in the popular spreadsheeting program Microsoft Excel. The problem behind this algorithm is to create a schedule for a sequence of jobs based on their dependencies on other tasks to be completed first. The topological sort algorithm outputs an order for these jobs to be performed in. The algorithm is run on a directed acyclic graph, or DAG, in order to create a hierarchy of the connected components based on their connections. We'll call the set of all vertices in our graph V. It locates a vertex in V that has no incoming edges. Since there are no cycles in a DAG and all arrows are directed away from this node, it must be placed at the top of the ordering. Then this node is removed from V along with all its outgoing edges. Because this graph is a DAG, it can be proven that there will always be at least one vertex without any incoming edges. This proof allows us to iterate our algorithm till the set V is empty. Each iteration, we add the node with no incoming edges to the next spot in our hierarchy and remove it until we are out of nodes and we have found our topological ordering. Let's see an example of how Microsoft Excel manages this algorithm to edit its cells. So let's say we have a very simple spreadsheet of 4 boxes. Behind the scenes, Excel keeps track of the relationships between these cells in the form of a topological ordering. If a cell depends on another cell to compute its value, it can be represented by an incoming edge in a DAG between the two. The benefit of storing the data this way is that we can change a value at any point and easily determine which cells need to be updated in addition to the initial cell. We can represent this set of data as the following topological order using this method. The algorithm begins by looking for a node with no incoming edges. We can see that A does not rely on any other cell to compute its value, so we choose A as W. The algorithm removes it from the set of unordered cells along with all of its outgoing edges and adds it to our output. Now, since we've removed A, B has no incoming edges, so we choose B as our next W. In the same fashion, B is also removed and placed next in the hierarchy with an edge connected to A. Continuing this for the other two edges, we will get the following topological map. Now let's explore the usage of this graph we've created by changing the value of A. In order to ensure that every affected cell is updated, Excel simply has to start at point A in the mapping and update the value for every child of A by simply walking down the tree. In this case, we are going to change A to 14. Then we move to the child of A and update B to A plus 1, which is equal to 15. Then C is next, so we update that. And finally, we move down to D and update it as our final value of 450. Now, let's take a look at some of the implications of such a powerful program. A news program hosted by Jacob Goldstein on public radio since 1971 wrote an article on the impact of the electronic spreadsheet in business. Their guest was a banker named Alan Snyder, who had worked as an accountant in Boston since the 1970s. One key point from their conversation was the difficulty of banking before the electronic spreadsheet. He told them, a spreadsheet used to be an actual sheet. Even making a tiny tweak was a huge hassle. With the introduction of electronic spreadsheets, Snyder says that it gives the user the power of playing the what-if game. The software allowed for the easy answering of questions like, what if I hired more employees? Or what if I charged a little less for my product? And Excel gives the users the power to do so through the extremely quick editing of tons of cells with little effort. Wall Street would universally adopt this program, but this wasn't always for the better. Several companies have been noted to lose millions of dollars over simple mistakes made in Microsoft Excel and other spreadsheet programs due to their employees' lack of understanding of the algorithms behind Excel. The most cited example by far on the topic happened fairly recently when JP Morgan lost $6.2 billion in 2014 through a series of mistakes when doing an action as simple as copying and pasting data from one sheet to another. The claim that one key measure was added instead of being averaged, which gave the perception of a bet being half as risky as it turned out, costing the company a fortune. These examples aren't just costing companies money, but there are people with jobs at stake behind these companies. For example, in 2015, the Utah Office of Education underestimated the number of students that would enroll in public schools, leading to a shortfall of $25 million in their budget. The error was attributed to a faulty reference in a spreadsheet, and 2 of the state's top finance officials were fired for their mistakes. Although many algorithms have revolutionized the world as we know it, the misusage of these algorithms can be very dangerous, and in the case of the topological sort algorithm implemented in Excel, the changing of a few numbers can cause a ripple effect with gigantic consequences.
Thank you for watching our video. We hope you enjoyed it.